Okay, ladies and gentlemen, welcome to another edition of Tech in 10. Today I'm going to be going over the Z87X-OC Force. This is Gigabyte's top-of-the-line overclocking motherboard. It has 16-phase IR digital voltage regulator module, some really nice heat sinks. They do have water cooling as well as two fans, and some people have mixed feelings about those. However, this board is just over the top. It's really feature packed, and we'll go over all those features, and we'll go over all the overclocking features specifically, as well as all the new features Gigabyte has brought to the table. So let's start out with the heatsinks, right? So this board has two separate heatsinks. These are not attached. This is really good for overclocking for a couple of reasons. First of all, you can just remove the VRM heatsink and insulate the VRM area, and then have a heatsink on things that actually need to be cooled, such as the platform controller hub, the chipset, as well as the PLX bridge right here. Now, when I say things that need to be cooled, I am being honest. You don't really need to cool this voltage regulator module. They're using IR3550, 16 of them. This is the same type of quality as we saw on the UP boards from Gigabyte last generation. They're basically the cutting edge of voltage regulator circuitry that you can get on a motherboard these days. There aren't many motherboards that can outdo this in terms of voltage regulator. The chokes can do about 35 amps. You have a true 8-phase voltage PWM from IR, the IR3563B, which can actually do up to 2 megahertz per phase switching frequency. Of course, this is doubled with some IR3599s, and we'll see that in a little bit. But Gigabyte has locked the switching frequency on purpose because it's not really needed to increase it for Haswell overclocking, because Haswell has an integrated voltage regulator in the CPU. However, that integrated voltage regulator also needs some power from the motherboard as well. Well, it needs all its power from the motherboard, and then it'll take that and step it down just a tiny bit more for the different voltage rails inside the CPU. So both heatsinks have fans. They run pretty cool, and they can be unplugged. Each fan has its own little Nuvoton controller on there to control it, and it has its own direct feed signal to the temperature of the CPU and temperature of the PCH for this fan. Actually, temperature of the VRM, I believe, for this fan. The fans don't run very loud. However, you can see that they do have a lot of fins on them too, and they're pretty high quality. I think Gigabyte picked these just to make sure that they didn't make too much noise. The water cooling setup has some barbs here. I think they're about 3/8 inch OD copper tubes. One copper tube goes through, and it's like a heat pipe. It goes all the way up in here, just about the size of this heat pipe, but it's hollowed. Maybe it's a little bit bigger than this one. It's not very restrictive. I've actually unscrewed these heatsinks so we can take them off, so I'll take off this one first and unplug it. Okay. Woo! It's heavy. Heavier than I first thought. The contact with the IR3550 is pretty good. As you can see indent from every single one. And you can also see two little indents here, and that's for the PCA and the voltage regulator for the PLX bridge. You can see this is the tube, and this is where the water flows, so maybe it is about the same size. I can't tell you the exact diameter of the interior tubing. However, you can see the heatsink a little bit here. The air will blow and then flow out up here, these little slits. The G1 Sniper 5 actually has them coming out this way towards the GPUs, but this one goes through the top of the case, I guess, so if it actually gets hot, it removes it from the area. So you can see it's actually pretty heavy, and these heatsinks come from a new vendor. I believe they're Gigabyte changed their vendor, because if we take a look at this heatsink, we can see some excellent contact done with the PLX bridge right here, and that's what's important, because the PCH these days doesn't get very hot compared to the Z77. We can see that this copper heat pipe is actually like a little bear, and we can compare it to a heatsink like an actual heatsink. This is the Thermarite, not Thermarite, sorry, this is Spire Eclipse 2, and you can see this direct copper contact. Same thing going on here, which is really nice. I actually have that heatsink around just to ground myself before I touch the computer or the motherboard. You can actually ground yourself on stuff like that. Anyways, this isn't using the same thermal pad as anything else I've seen before, but it is doing a good job of cooling the PCH. See a little fan connector here, a little connector here, and we can kind of see how everything is done. It looks pretty nice. They've done a great job with the looks of these heatsinks. So anyways, put that to the side, and now we'll take a look at the motherboard circuitry, because I like the motherboard circuitry, sorry about that. First, actually, let's do the back panel I/O. So, the back panel here, let's see if we can focus a little bit. Okay, 7.1 audio from an ALC898. Dual NICs, both of them are Intel. One is 217 or i217. The other one is i210. The i210 is its own discrete chip, and it's a pretty damn good controller. It just released in Q4 of 2012, so about December, October, November, something like that. Dual HDMI right here and right here. So I asked them why we have dual HDMI on these boards and why I would even use dual HDMI, and they told me, Gigabyte, I actually had to ask a project manager to get a straight answer, and they told me that basically you can use one for audio and one for video if you like, because a lot of users have been asking for this. They've been asking because they have like DACs or new things that actually take in HDMI, but they don't have throughputs. So if you're using HDMI for that, then you can have dual HDMI outputs, which are basically clones of each other. So yeah, here we have DisplayPort, SPDIF out digital, 6 USB 3.0. Nice, and 2 USB 2.0 as well as PS/2 with a lot of gamers and overclockers alike. I use PS2 as well. It's just a failsafe, you know. Okay, so putting the board back. Let's move the board over here so we can see some of the OC features first. I'll go over those because I think a lot of people are wondering what all these OC features are all about. So if we zoom in here a little bit, I think that's good, right? Okay. So first one we have is the power button. The power button turns on the computer. Duh. Then we have turbo. This will give you, and this is one of those switches that sticks in if you press it, 4.2 gigahertz overclock on the CPU automatically. Make sure you press this while the computer is off. Tag is basically the same thing, except you can set this profile with any BIOS settings. So you just put them and then you save them like you save a normal BIOS setting to a drive or to the BIOS itself, and this will actually save it into the tag profile. So when the computer's off, you can press tag and it'll engage the tag profile. Pretty cool, right? Here we have OC Ignition. OC Ignition works kind of in the same way, but you engage it when the computer is off and you disengage when it's on, not off. Anyway, so OC Ignition is an interesting function, okay? So let's say that you are overclocking with liquid nitrogen, but you want the fan spinning when the computer is off. Well, some people have a secondary power supply they always jump and use. Well, OC Ignition, will keep the power going to the motherboard. However, it'll keep the system off. Or the system will be off, but it'll keep the power going. So it won't interfere with the way the system turns on or off, but it will always keep the power going. But the CPU will be off, for instance. The memory will be off. But the PCIe slots will be powered, meaning that you won't lose your data on something like an iRAM. It also means that you can test your water cooling loops if they have pumps that work on a fan header, or if they have pumps that work on a Molex connector. You can actually test the PSU, have a load on the PSU, and not be afraid of breaking your power supply. Okay, so that's really what OC Ignition is all about. It's a pretty useful function. Here we have plus, minus, gear button, which sticks in as well and disengages. And then we have another plus and another minus. These two are for multiplier, and these two are for base clock. Gear ratio changes base clock from 1 MHz increments to 0.1 MHz increments for extreme fine tuning. It's a good granularity, so it's interesting. Reset button right here. No other buttons around there to confuse you. Then we have a trigger button. Trigger button is really cool this time. So before, when you had trigger engaged, it would take the CPU to a minimum multiplier. Here it's 8x instead of 16x on Ivy Bridge. However, with trigger engaged, you can still increase the max multiplier while trigger is engaged. So if I'm going from 8x to 60x, which is 6 gigahertz to 800 megahertz, so right now I'm at 6 gigahertz, press it, now I'm at 800 megahertz, so 0.8 gigahertz. But let's say I want to go back all the way, but I'd be at 6.1 megahertz. Well, I can press 1 up, and then I'd re-engage the trigger, or disengage the trigger, and I'd be at 61. And then I can go back down, press up again, and then go back, and I'd be at 62. And go back, you'll always be at 800 megahertz. Anyways, these are voltage read points. This time the voltage read points have to be directly routed to the pins on the CPU to read them. So it's not going through a chip, it's actually hardware routed to the CPU. So only the manufacturer can provide them to you. So Gigabyte's put them on all boards M5 and up. That's a Sniper M5. Last time Sniper didn't have any OC features, but this time it does. We have a postcode display here. Very nice. ADH, port ADH. Okay. And then here we have some dip switches for the PCIe slots. These will disable all the orange slots. Here we have a clear CMOS button. Really simple, right? And here we have 2 switches. You can see one says SB and the other one says BIOS switch. SB is single BIOS, dual BIOS mode. So BIOS switch is simple, right? Between main BIOS, backup BIOS, main BIOS, backup BIOS. Single BIOS, dual BIOS mode is different though. Okay, so it'll disengage the dual BIOS mode. That doesn't mean you can't switch between BIOSes, you still can. Going to single BIOS mode is like being on any other board with two BIOS ROMs. They don't use the same technology because Gigabyte has patented this technology. However, single BIOS mode is like what they use. So if your main BIOS corrupts, you can just switch to the backup, no fuss, no worries. The backup will be there, but the main will still be corrupted. Going back into dual BIOS mode, we'll have the backup check the main every time it starts up. And if the main is corrupted, it'll flash it. Even if you're on the if you're on the backup becomes the main, and the main will check the backup. So it's pretty cool. However, dual BIOS mode has another issue. Dual BIOS mode does, like what I said, it checks the main main BIOS every time. However, if you're overclocking, this checking time can really mess up OC recovery, especially base clock OC recovery. So if you OC the base clock too high, then you want to recover from a bad boot or something like that. Dual BIOS mode will make it take about maybe like 5 reboot cycles. However, switching into single BIOS mode will only take maybe like 2 reboot cycles, maybe 3 reboot cycles. So it really helps save time, and that's the only reason it's there. So if you remember on Z87, if you saw the DB error on the postcode, that's because of dual BIOS mode. If switching to single BIOS mode will get rid of that kind of error. So that's pretty cool. And I think that covers all the OC features. So let's start over again at the VRM of the CPU and see what we can do. Alright, so here we can see 16 phases. We can also see that the 16 phases are all IR3550. IR3550 is pretty expensive, so you can't ask for too many of them. But 16 is a pretty large number for them, which is pretty awesome. I'm pretty glad Gigabyte used these again, because you really can't go up from them. It's really hard to get something better quality than these. IR3563B is the controller, like I said earlier. These are about 35 amp chokes, but you can never push more than like 15 amps through them anywhere because Haswell doesn't use that much power. Anyways, here are all the capacitors for the output. Here we see about 18 capacitors, right? 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, that's a lot. And I don't know why they did this, because all you need are these, and then these will take care of everything. However, these are all extra, and yeah, it might help with large transients because the capacitors have to assume the load while the inductors are charging up. However, I think it's just for marketing purposes, and it does increase the cost of the board because output capacitors are one of the most expensive parts of the VRM. I mean, here the IR3550 are, but in general, they're the most expensive parts. So I was kind of surprised when I saw so many. The UD7TH also has the same OC features and the same number of capacitors. Something to mention about the socket. This socket has 15 micron layered gold compared to maybe like 5 natively or standard. So do the PCIe sockets and the memory DIMMs. They all have that extra the extra gold. So it's pretty cool. Anyways, let's move down here a little bit. Okay, so let's take a look at the memory VRM. Memory VRM is surprisingly also using IR3550. You usually don't see that because that costs a lot of money, but here we see it. They're using a IR3570 as the controller, as a PWM controller. And that's a pretty high quality controller. 3 phases are being routed directly through these IR3550s. They don't require drivers because the drivers integrate into the power stage. The 2 other phases are going to the PCH regulator. Anyways, we can also see that this the interior of the 24 pin and the 8 pin and the 4 pin over here, they're all plated gold as well, which is new. Gigabyte hasn't done this before, and they're trying to see how it will go. But anyways, yeah, so that's another feature. And then here we can take a look at the USB 3.0 slot. This is an on-off charge USB 3.0 slot, and we never saw this before on Gigabyte boards. However, this time we're seeing this. And it's supported by 2 chips here. They're TPS 2546, and they're specially made just to fast charging of USB 3.0. And you would need them to do on-off charge of USB 3.0 and the fast charging. Here we see the extra MOSFETs for the PCH VRM, right? Okay. that covers most of the VRMs. Now we'll go to the special features. Here we have a USB 3.0 hub. Now this is a 1 to 4 hub, so one USB 3.0 port routed to it will output 4. If we look at the PCH, we can also see that it's new, and the PCH actually supports up to 6 USB 3.0 ports. However, that number can go up and down depending on how many PCIe lanes you want on the motherboard. And here I think Gigabyte chose the 666 configuration, so 6 USB 3.0 and then 6 SATA 6, which are these black SATA ports here. These are all Intel. These two are from Marvel, and the Marvel SE9230 provides 4 ports from 2 PCIe lanes. So count this, right? 2. We have a count of 2. Then if we go over here, we see 2 PCIe 1X slots. They're both take up 1, so that's a total of 4. Then if we go over here, these 2 are the NICs, and we'll cover them later. Those take up 1 each, so that's also 6. However, nothing else on this board is using PCIe from the PCH, so that leaves room to have 6 USB 3.0. If you had 4 USB 3.0, then you could have 8 PCIe slots. I think each of these hubs maybe can take 2 USB 3.0 ports, and if they can, then that'll provide more bandwidth to them in case you want to fill up all the ports. Anyways, this hub that we pointed out earlier provides 2 to this lane, and then 2 to the back panel port inside this first little metal casing next to the audio outputs. Now there's another USB 3.0 hub right here. This is the same one. They're both NEC/Renaissance D720210. So D720210, and they're the latest generation ports, and they are pretty damn good. Anyways, moving back to this area, so we can look at the ITE Super I/O right here. It's very commonly found on most Gigabyte boards, and it provides okay fan support and stuff. On the other boards, they're just using this, and they can get about 3 fan ports out of it with full control. However, this board has extended fan control because of another chip, and let's move the board over here so we can get a better shot of it. Now, this other chip is known as something called EC. It's called an embedded controller, and it's Intel technology, and basically it allows for better fan control and stuff like that. I can't zoom in that far at this distance. Anyway, so this is the ITE 8790E, and you really can't find a datasheet on it because it doesn't exist. I think it's especially made for Gigabyte, and they can customize for whatever they want. Then there's the EC BIOS, which provides functionality to it, and that's what really provides a lot of the fan control on this board, as well as some of the other features, some of the OC features. However, it also provides something else. It also provides all the, it takes some of the BIOS functions off the BIOS, and it also allows you to store profiles after clearing the CMOS. So your tag profile will still be there after you clear the CMOS. So will all your saved profiles. It also allows 2 different CMOS settings for the different BIOSes, which wasn't there before. Anyways, moving up a little bit, here we have a TI drivers and receivers chip. This provides functionality for the COM port, which is right here. Okay, and we can go to these chips right here. Let's zoom out a little bit because there's a bunch of them, and I'll cover the PEX chip right now as well because it seems pertinent to what we're talking about. So as we see, we have 4 orange slots and 1 black slot. This black slot is a PLX bypass. So let me zoom out so you can see the whole thing going together. Zoom. Good. Okay, so PEX 8747, 48 lane bridge chip. It's basically a big switch that takes bandwidth and shoves it wherever it needs to go. Now, it gets 16 lanes from the CPU and then 32 downside. So that's total 48. That's what it means when it says 48 ports. Anyways, the PEX chip. These 8 PCIe ASM 1480 switches are all PCIe 3.0. Each of them can switch 2 lanes, so 8 of them, 16 lanes. So the CPU's PCIe goes to these chips first. If you have a GPU in this slot, then they'll just be in this slot, and all the orange slots will be disabled, as will the PEX bridge. However, if you want to do more than 1 card, and you put any card in any of the orange slots, it'll switch all the lanes to the PEX chip and disable the black lane. And then when it's at these orange slots, 16X goes here and 16X goes here, so 2-way in these 2. However, if you do a card in here or here, these 4 switches will switch 8x from here to here. These 4 switches will switch 8x from here to here. So you understand how it gets its multi-GPU functionality. This board does support 4-way. Okay? And also, this SATA power connector provides extra 3.3, 5, and 12 volts. Basically about 50 to 33% more power for the PCIe lanes with that. Okay, so let's zoom in a little bit here. Maybe I can get a little closer. Okay, so here we have the ALC codec. This is an ALC 898. However, it has two audio amplifiers. Both of them are DRV632, made by Texas Instruments TI. One of them provides to the audio port here, and the other one provides to the green audio jack on the back panel. So pretty good audio. Look at all those nice capacitors. These capacitors are especially made for Gigabyte. Anyways, these are two controllers. This is a i210, brand new controller, launched in Q4 2012. I think I already talked about this. And this is the i217V. This works with the integrated gigabit controller in the PCH. However, this has the gigabit controller and the physical layer device all integrated in here. So this is all in one, and this is just a physical layer device PHY for the chipset. So that's pretty cool. That's why they're different sizes. I'm pretty sure you can team them too because they're the same. So that's the VRM, controlled by a RT8120D, something like that. That seems what it usually is. If we move over here, we have two chips here. These are HDMI level shifters, or DVI/HDMI level shifters, and this little chip behind this capacitor here is a Nuvoton fan control IC for this. There's also one down there for the other fan header. So the digital video is a native output from the CPU, iGPU. So DisplayPort doesn't need a level shifter. However, HDMI and DVI do, so there's two here for both HDMI. So I think that covers everything on the board, right? I think I have covered everything. Okay, so this is the OC Force, one of Gigabyte's top-of-the-line motherboards for this platform. If you have any questions or comments, please post them in YouTube, online, on my website, synhardware.com, or on any of the forums I frequent, like overclock.net. I hope you enjoyed this review, and Syn out.